Hey guys, welcome to another Lab Live. Today we are going to be talking about generative design, and we have the very famous Ben Guler, our Chief Technology Officer, and our design technologist, Clara Fontaboa. Clara, how do you say your name just so we say it right? Because I never roll the R right. How do you say it?
Clara Fontaboa.
Thank you very much. I'm not going to attempt it, but I love it. It's a very pretty name. Today we're going to be talking about generative design. It's one of those buzzwords. There's a lot of hype in it. There's some really cool products that are coming out, different startup companies. You have big companies like Autodesk that are pushing their generative design tools. And so there's just a lot of fog about what generative design is, how people are using it, and hopefully trying to bring some clarity to that. So with that, I'm going to turn it over. Actually, Ben, do you mind giving us the lowdown on your interpretation of generative design? What is going on in the industry around this concept?
For sure. So there's, like you said, Bill, this is a very popular buzzword at the moment, and it can mean so many different things. If you think about it, a lot of things could be generative design. You could say a Dynamo script generates a design. Even AutoCAD, you could say it's generating design. A smart block it's generating whatever set of rules you set that you automate is generating something. And then if you extrapolate that and you zoom out, you could say it's a design. However, there's two things that I do want to touch on, and one is generative design as a concept, which I won't really get to an actual definition on. I won't maybe zoom into something. I might give you an opinion what I think it is, and then I do want to touch and make the difference in between the generative design tool within Revit, which is a product of Autodesk, and how they're using that same kind of verbiage for that tool. So generative design as a big concept is, to me, is something where you set certain instructions and certain relationships, and that set of instructions and relationships produces something. It could be a bubble diagram, or it could be a schematic floor plan, or something that's whatever the set of instructions you set it to do, it generates something. So that's very vague, but I want to touch on how others are using generative design, and how kind of from a marketing point of view, they are classified or attributing this name to their product. So what we have in front of us is kind of like this branch, and we have kind of generative design in the beginning of this tree structure, and you could see all the different kind of branches and some of the different products that are out there that are pretty popular that use this terminology. So if you look at the top, we have McNeil & Associates that provide Rhino and Grasshopper, and you could see how via Grasshopper you could have Galapagos and Wallasai. So those two plugins within Grasshopper. So Grasshopper, you could pretty much visually code your relationships, your design, and what you want the design to be. But then you can have certain parameters that are variable inputs. And those variable inputs, as soon as you change it, let's say in the form of a slider or a drop-down option, or like A, B, C, D, whatever those variable inputs are, as soon as you change those inputs, the output, the design, the generated design changes. So if you look at, let's say you look at this from a brute force point of view, where you try every possible combination to see every possible outcome. Changing let's say the list input is from 0 to 10. So you go through 0, 1, 2, and you go one by one through every single iteration. And that's for the first slider. Then you'd run the same thing for the second slider. So you kind of go through all the possible options. That would be a generative design that has thousands and thousands of options. However, with Galapagos and Wallasai, it doesn't do it that way. It actually uses something called a genetic algorithm, or other people will call it an evolutionary solver. And that evolutionary solver goes through these options and these inputs and outputs, and has some kind of intelligence on how those inputs affect the outputs. It finds a loose relationship between them and graphs them, and is able to actually produce less output, but output that matters more. Still, this is a very slow process, and it could take up. It's a very complicated problem. So the more inputs you have and the more outputs criteria you have, the more complex the problem is, and the longer it takes to solve. But in a sense, that is generative design, and it's in a way where it's using an evolutionary solver to iterate through many different options and score them, and then present the user with the best options, and those best options would be, there's not the best option, but each best option has pros and cons. So if you want to maximize a sunlight, this option might be best, but it's at the sacrifice of possibly your HVAC units. You need to scale that up, and electrical load maybe. So basically, you always have pros and cons, but the user's presented with options that they could get to choose from. So that's kind of within that Galapagos Wallace AI branch. And if you look at Autodesk, the analogy there and the kind of the analogous pieces of software there, the same way Dynamo is to Autodesk Revit, it's the same way Grasshopper behaves with Rhino. So Dynamo is really the code where you're setting up your ingredients and what the inputs and outputs, but the generative design tool, pretty much similar to Wallace AI or Galapagos, they're very like each other in products, is pretty much a evolutionary solver that uses a genetic algorithm to run through all the inputs in your Dynamo script. So you always need to have that Dynamo script to run through and actually set up all the different relationships, the inputs, the outputs. And as you have your Dynamo script ready, it basically what the generative design tool does within Revit, it actually changes those inputs. So if you have a slider input in Dynamo, or if you have a different types of inputs, it basically runs through all the different options in a smart way. So if it notices that getting closer to a certain integer, it's going to test results within that bracket. It doesn't try every possible combination, because that kind of a problem would be impossible to solve given the amount of resources we have and computing power at the moment in our technology. So basically, the Revit generative design tool is pretty much an evolutionary solver. It will become more in that category. But however, it is branded as generative design within this bigger umbrella of generative design. If we look at Hypar, and again, this is very broad level, so correct me guys on the specifics, but it's pretty much a shell where you could do all these different things. All these different platforms could find themselves in this cloud platform, and it's more of a shell for all these things, but under the understanding that by combining all these different algorithms, and if you want to have an evolutionary solver, you combine that, you could pretty much generate options similar to how you would see them via Grasshopper and Galapagos, or Grasshopper and Wallace AI, yep, and Rhino and generative design tool. If we look at TestFit, that one actually does not at the moment use an evolutionary solver, but it's still kind of classified under this generative design umbrella because it generates design based on your inputs. So it doesn't actually need an evolutionary solver, which they're actually really slow, these solvers, because it tests a bunch of different scenarios. It actually just uses a set of rules that are and algorithms that are very intentionally programmed so that you have an interface that is very snappy and you get very immediate return on the inputs that you put. So it's a very, very efficient and very fast tool there. The other tool that's been kind of out there that people have looked at is Finch 3D, and that one is based on using Rhino and Grasshopper. And that tool, I don't know at the moment if they actually use an evolutionary solver, but it does use a robust set of rules and tools and algorithms that actually takes in the input and generates something out of it. So if you give the input of certain lines or you move a line, there's a rule-based algorithm that populates that area that is now generated with objects or a respacing of objects. However, if they don't use that evolutionary solver, it wouldn't. It won't give you a bunch of different options yet, although we could all see how that could benefit if they start to do that. But basically, this is a big picture of where we're at, and I'm sure it's not inclusive of everything that's out there, but these are some of the technologies and some of the things that are buzzwords out there that people kind of start to label their software as generative design. However, there's a bit more nuance in that, and I want everyone to understand that when you are using the Revit generative design tool, it's something very specific within this branch. It's not, it's kind of rebranded for this tool, but before, for example, it used to be called Refinery or Project Fractal. It's more of a evolutionary solver in this kind of a landscape of tools that are out there. So for the next parts of this talk, we're just going to go over the Revit generative design tool and show you guys how we can set it up, what it does, what the inputs are, how you can set up the inputs, and how the interface works, and all the different inputs and outputs that we could use. So without further ado, we'll hand it off to Clara.
Before we go there, real quick, I just want to question about that. So similarly to how people used to kind of interchangeably use the word BIM and Revit, I remember there was a big push for people to really make a separation. You know, Revit is not BIM, BIM is not Revit. So to your point, Ben, generative design isn't necessarily exclusive to just Autodesk. There's other players in the space that are also building out their own generative design tools. Is that right?
Definitely. And I think the distinction there is BIM could be many things. You could actually have SketchUp to be BIM. If you set up the certain rules and the output is classified in certain class objects, and BIM is pretty vague. Basically, it's building information modeling. So if you attribute smart and you have smart classifications of those objects that you could parametrically rebuild, then yes. So with scripts, for example, even SketchUp could be BIM, or ArchiCAD is another example of BIM. Rhino could be BIM, and is BIM in certain, if you program it and if you have those relationships set up in such a way, it is BIM, because that data could transfer from platform to platform in a BIM fashion, if you will. In terms of generative design, it's this overarching theme of letting the computer generate a lot more than maybe we're used to at this moment in time. Maybe down in the future, maybe a few years from now or a decade from now, generative design, that will be like, we shouldn't even use that word for what we're doing now. That's probably called something else. And generative design in the future might be labeled as, well, you have a paragraph in a sentence or an essay that gets translated into, these are requirements, into an actual building. And I'm just kind of making stuff up at this moment. But basically, it could be artificial intelligence that actually abstracts language to generate a design. And so we could see how this label of generative design is actually a moving target. But right now, at the moment, it's being attributed to a few different things. But I do want to point out that a lot of these things are, in the past, they have been labeled or have been classified and spoken about as evolutionary solvers, and not just that, beyond that.
I like it. Okay, cool. Thanks, Ben. And then while we're jumping into Clarify, what I'd like everyone to do in the comment section, if you don't mind, is I think it's still open for debate, in my opinion, the definition of generative design and how that definition evolves, if you will, no pun intended, into where the industry goes and how it's used and where the computer stops and the human begins. Those are some other questions that I have for Clara and yourself, Ben. But I'm curious if you guys in the comments have any other clarity or your own opinion on what is generative design, or how you're using it, or how you see it changing in the industry. If you guys could leave that in the comments section, because we want to have this dialogue and this conversation around this. We don't want it to be so much only a presentation, but also a dialogue. So if you could leave in the comments your own definition or areas that you feel like we may have missed the mark, or you have your own perspective on that, we'd like to know some of that as well. So with that, unless Ben, you have anything else, maybe we jump into Clara's part.
Yeah, I think I'll interject in different points. Maybe one thing I do want to mention before we continue on is that with the Revit generative design tool, it's using Dynamo as a backbone. So what it actually does is it actually opens Dynamo like quite a few times on different threads on your computer, and it runs that script with different inputs basically, and then it merges all those results into this kind of canvas of I tested this input, and I tested this input, and this is what you'll get. And it presents those results in that kind of thumbnail fashion, in that when you start to explore the different outcomes, and we'll get through that in a moment.
I like it. Cool.
All righty.
All right, so
I think the floor is yours.
Now it's my turn. Okay.
Yes.
So I'm going to start with a simple script that we made in-house, which is I'm going to be using this wall here, and it's going to create tiles on this wall with 2 different colors. And I'm going to talk about the script and how generative design can be used to generate multiple versions of this title pattern. And then we're going to go into a more complex script, which is the workspace layout by Autodesk. And I'm going to also show some modifications we made to be able to use a different kind of furniture for a different kind of solution. And yeah, I don't want to go ahead too much. I want to talk about the title pattern first. So let's go to that. So
Awesome.
I'm going to start in Dynamo because, as Ben was saying before, everything, the backbone of the generative design is actually Dynamo. Everything depends on a Dynamo script that you create yourself or someone else create, and you just using it to generate the options. So I have Dynamo open here, and this is the script that generates the tile pattern. So I want to make sure this is closed. I'm going to run the script once so we can have an idea of what it's generating. So here in the back, you can see that we're generating this surface, or actually multiple surfaces, and it has two colors. It can be either white or green. So this script is not defining which color each title has. Okay, so in basic words, this script is first it's selecting surface inside of Revit, and here we are also creating two different things in that surface. We're creating a point, which is going to be our attractor point, which means that is going to calculate the distance of this point to all the titles to help define the colors. And we have two inputs for that attractor point, which is the U and V placement.
Can you turn that on?
Yeah. So yeah, so our point is right here, and you can see if I change these parameters, that point is going to, let me do that.
You might just have to hit run again, don't you? Or put it on automatic.
Oh yeah, let me put it on automatic. Thank you. Yeah, so you can see that the point moved to a different location, and it's changing the pattern in the way.
Okay, in and of itself, that's pretty freaking cool. For someone that like is had to lay out tile patterns in bathrooms and hospitals, like that's pretty cool, Clara.
Yeah, thank you. So yeah, that's what the attractor point is doing. And the second thing that we're getting out of this surface we selected is a subdivision and a grid subdivision. So which is defining the sizes of these titles. So this part here is what's doing that, the phase tiling subdivision. So if you see I increase the quantity here, then the more titles we have as an output. And here is when like the actual process of generating these colors is starting. So what it's doing is making the titles that are closer to the point to be white and the further away to be green. But do you have a comment?
Oh, no, got it. Oh. I was wondering about that.
Yeah, so yeah, it has some randomization, and that's why it's not so clear right now, but we're gonna get that right now. So besides the point, the distance to the attractor point, we are also adding a randomization modifier. We call it randomization modifier to give a little randomization, so it's not like everything white and everything green. So I can actually show how that actually works right here. If we decrease the randomness modifier, you see that we lose this randomization in the pattern. So the bigger we have, the less important the distance to the attractor point is. And more randomization we add to the system.
Okay, so deep philosophical question for you guys. Is this generative design? We haven't even gone out and used the Revit generative design tool yet, but we are generatively modeling on the surface of this wall. At the very least, we're generatively modeling. Is this generative design, or do we need to have some kind of optioneering parallel chart to call it generative design?
Yeah, I don't think that you need that optioneering thing, because there's going to be tools that you just have inputs and you have the output by giving the same ingredients as the input, you'll get the same output every time. But if you change your ingredients just slightly, the inputs, then you get a different output. And so if if you need an evolutionary solver to classify it as a generative design, then maybe TestFed.io is not a generative design tool, which I don't agree with. So this is generative design, and it's designing a tile pattern on a wall. It's not designing an entire building, an entire floor plan, but in my opinion, it is generative design, which shows the broad and breadth of what that is and how people might actually misconstrue that for certain things that it's not. But if you're looking at an architectural plan or a BIM model that gets generated, then it's a very specific branch within generative design that's called, maybe generative floor plan design, something like that.
That's great.
And I also think that what the difference between what Dynamo is doing here and what the generative design does is just automate multiple options, because you can come here to Dynamo and just play with the inputs until you see the result you want.
Right.
But what generative design is doing is creating many options for you already, so you can look at all of them together and make a decision then. So yeah.
Right, so instead of you manually exploring and running and pressing automatic or pressing run on this script, what the generative design tool in Autodesk Revit is just automatically changing those sliders in a specific way that actually meets certain goals. Like if the outputs, if you have a watch node and you set that as an output and you say, I want to maximize this number as an output, then I will move these sliders such that that output is maximized. So it automatically slides these sliders and runs the entire definition many times, and that's how it presents you with those options that are the best options to pick from.
Yeah, and we're gonna get that soon, because I want to actually use this example to go through all the 4 methods that generative design have, and evaluate the difference, understand the difference between the 4 and what actually produces differently with the same script.
Right.
Okay, so before we go there, I just want to go back here to the randomization process, which I think is what makes this script very interesting. So let's forget about this random seed. It's not an input anymore. And let's focus on this randomness modifier and percentage of color 1. So color 1 is, and let's test that. Color 1, I believe, is white. I'm going to put this to automatic and see if you have, so if you have 20% of color 1, then you have very little white. And if you have a lot of it, then you have very little of blue, green, cyan, that color that we have in our logo. And assigning more or less randomness based on how much randomness you put here on this input. So if you have 0, you have 0 randomness, and only the distance between the point and the tile is going to define the color. If you have more randomness, then the distance basically fades away, and you just have the randomness defining what color each node is. Excuse me, each tile.
Makes sense.
Okay, so after that, we have 2 different outputs. First, we have this visualization, which is what generating the geometry that we see in the back here. And then we have this one that we already played with a little, which generates a generic model for each tile inside of the Revit environment and apply 2 different colors, or 1 of 2 different colors to each of these tiles.
So maybe one thing that we might want to touch on is how you right-click on inputs to show that that's how you define them, and that's what transfers into the generative design tool.
Oh yeah, that is actually, thank you. That is a very good point. So so I have many inputs here, and I'm not using all of them as input inside of the generative design. So To do that, you right click on your input and define it as input. And here you can see that I'm also defining it as an output. And that's going to make more sense when we start talking about the random, no, which one? The optimization method. Because if you set it as an output here, then you can use that value to become a goal in a constraint within the settings that we put before doing the study. Yeah, so I added everything here. I also added this one because then it's getting the face. And you can see I'm not using these ones. I'm just using it as an output because I don't want the generative design to be changing the sizes of my tile every time it creates a new version. I want the faces to always stay the same. Yeah, any more comments?
No, I think that's really good. And I think one comment that I would say that might go a bit beyond this script at some point, I'm sure we're going to touch on, but you can make watch nodes as outputs too. So if you have a watch node of, like, let's say you have a lot of computation and the goal is to maximize a certain objective, you just put that into a watch node from another one of the nodes. And then let's say if that watch node is like numeric, then you could put, I want to minimize this value, or I want to maximize this value. You could make that watch node as an output, and then the evolutionary solver actually attempts that.
I don't think it's going to make much sense to do this here because...
Let's not do it here.
Yeah, I could just simply set this as an output and the result would be the same, since it's just like directly from the input. And in another note about that is that this script particularly is not designed to be like an
optimized or something that's
optimization one, because it's just trying to create multiple versions. Right. That is not actually an optimal solution that you're trying to achieve.
Right. We don't want to maximize or minimize anything in this specific example, which makes a lot of sense, actually. It's just kind of an aesthetic exercise.
Yes.
That was actually, sorry to keep bringing up philosophical questions, but so for a lot of this, generative design is good. Like if you're trying to maximize floor area ratios and departmental adjacencies and maximizing profits for investors, etc. We're actually, to that point, we're not optimizing anything per se then, where it's mainly just an aesthetic exercise. And so these principles can be applied towards architecture from an objective subjective standpoint. You could actually use generative design for kind of more subjective design studies then. Is that right, Clara?
Yes, yeah. So you can use different forms of generative design depending on what your goal is. And for this case, like the generative design has multiple options and options of methods, and sometimes your script is more relevant to use for this method or this other one, depending on what you're trying to do. The second script that we are going to show, which is the layout, it makes more sense to be an optimizing one because we're trying to probably add the more tables that we can inside of that room based on the other values or parameters that we wanted to use as parameters as well.
Like it.
Now that we understand all the scripts, I'm going to export this study to be using generative design. So you go up here and you export for generative design and export. Okay, so now that we did that, we don't have to open Dynamo again to create a solution within Revit. We can just go directly to the Revit ribbon and use the generative design tool in there. So the way this is going to work is we're going to go to manage and create a study. Let's opening this. Here's going to give you a couple examples. Some of them are the examples that Autodesk already created. And here we're going to use this one. And here we're going to start playing around with these inputs and outputs that we selected to generate these multiple options that we're trying to. So first thing first, I'm going to make sure I'm selecting the wall I want, or the face I want. And let's start with the optimize method, which, as we talked before, it's not actual intention of this script, but I want to show the differences. So for this method, you have the variables, which are the inputs that you define as, which are the parameters you defined as input in your Dynamo script. And you have your goals, which is what you defined as output. Also the constraints, which is also based on output selection in Dynamo. So in this case, we wanted to keep all these variables, but I don't want to add all these goals. I think I'm going to add the randomness modifier as a goal, and I want to maximize it. So I want more randomness than non-randomness. And I also going to set it as a constraint from 0.2 to 0.8. So you don't have like maximum. Actually, I'm going to shrink this to 0.7. So you don't have like a total randomness or total non-randomness. And you can also set other inputs here as a constraint too. So for example, if I don't want the point to be like right in the edge of the surface, the attractor point, I can add that as constraint here. So I'm not going to do that for this one. And I'm going to just do, I think I can keep this. So yeah, let's generate our study. Sorry, Bennett, were you going to say something?
Nope. I just thought that was funny that you were you were talking about that input. I'm like, I'm not going to do it. So I'm just going to talk about what it was doing in the background. Basically, in the background, it opened up Dynamo, maybe multiple instances of Dynamo, and it generated results by changing all of those values really fast.
Okay, so this one was the optimizing method, and it's trying to optimize the randomness. So we can see that it has pretty much a lot of randomness on all the options it created.
Can you show how you could edit the parallel graph to start to kind of just filter out certain options by dragging?
Can I?
If you go back to the parallel graph chart.
Yeah.
This one?
Yes. And then you can drag it up or down on those vertical bars to start kind of optioneering which ones you want to include and not include. It filters them out.
Oh, so like this?
Yep, exactly.
And it's just filtering those options. Oh, I didn't know that.
Yeah, cool. Yeah, you can do that.
All right.
The two options kind of fit within those ranges that you just selected right now.
No options fit within this range now.
So you might have to clear and redo some of those, and yeah.
Nice.
Yeah.
Oh, well, I'm learning too. Yay.
There you go.
Okay, so let's create a new study now. The same one, but this time, I want to move this over here. We're going to use a cross-product option method. The face is still the same. And I'm going to keep it like that so it doesn't create too many options. But in this case, what it's doing is just, and please help me, Ben, but it's getting only the maximum and the minimum value for each one of these inputs and creating an option for that. So I'm actually gonna put 3 here.
Yeah. Or you could even put 4, maybe it might take too long. But basically, you can see immediately that the inputs are vary now. You don't have any goals anymore. You don't have maximums and minimums, and you don't have any goals. It's just, this is kind of a brute force approach where it actually explores everything that's possible. So if you look at number of variations 3, and you have 0 to 2, then it's going to have like 0.33, 0.67, and then 1, for example, or whatever that divides up to. I actually probably have the numbers wrong. But it only gives you three numbers within 0 to 1, if that's the range, for example. But if you add 4, then it gives you 4 numbers that's going to test. So if you think of this as a slider, it's going to move the slider 4 times as an option. If you do 2, then it's actually really the minimum and the maximum. So you get 0 and 1, 0 and 1. So if you only keep it at 2, that's where you get the min and the max. But as soon as you increment that number to 3, 4, 5, like 3 will be the midpoint. So actually we'll get 0.5. So 0, 0.5, and 1.
Yeah, and here we can see the total of outcome that is creating, which is just multiplying all these numbers together, and that is the total results that you're going to get in the end.
Correct. So if you multiply 3 times 2 times 2 times 2, you'll get that. And also keep in mind that you could actually do less iterations at the first batch. And then let's say you find out a sweet spot where I think I want to explore this path. Then you could just actually minimize within those iterations and just kind of explore solutions using those values that you've identified.
Sorry, yeah, so as an analogy, I don't know if you guys have ever seen like the diagram, but one of the ways that really helped me to understand cross product is if you almost think of like a shoe with shoelaces and how it goes through the different eye holes. You're basically touching multiple options as it relates to, okay, bottom hole directly across from it, bottom hole directly across and up from it.
I think that is a very interesting analogy. I love analogies.
Yeah, so if you look at the first input, we actually had 3 iterations instead of 2. So you could see right now that you actually have 3 kind of points that cross that line instead of the other ones. We only had 2, so it's only choosing the mins and maximum. But if you were to add more points, you would see a lot more nuance and more variation in what you have available. But then also that dramatically increases the number of generations that it's producing, because it runs that many more times the script. So in this example, that number of iterations was 24, which means the script was run by Dynamo with different inputs 24 times.
Yeah, and just to confirm, the U and V divisions, we're not getting a filtering result for that because those are fixed, right? You didn't change or give the input or output for a UV division to be a variable, correct? Those were fixed?
I didn't set them as input. So they're not being taken in consideration, but they are showing here because I set them as an output, so we can actually visualize the result within the Generative Design tool.
Gotcha. Cool.
Now let's go to the randomization, which is my favorite. Randomize. So in this option, it's similar to the cross product, where you don't have goals or constraints anymore. You just have the variables. But instead of doing the cross product and just getting subdividing the parameter values in as much as you want, it's gonna create random. It's gonna get random values from each one of these parameters. Is that correct, Ben?
Yep. So basically, instead of you saying 2 for each one, it's just going to randomize. I'll pick maybe, if you want 40, then I could do maybe, I might do 2 from 0 to 1, but it won't be 0 and 1. It will be maybe 0.33 and maybe 0.9, or it's going to be random. And if there's not enough solutions, if you only put 10, I'm only going to give you 1 random number for each slider. If you only put 4, for example, and you basically you choose the number of solutions you want. And based on that, the randomization happens within all those different sliders or those inputs that you have there.
Yeah, so yeah, this is a very small script and it's a simple algorithm. So nothing crazy is happening, and we already have all for the options. So we can see that by the end, it's actually start to get more random here.
Oh, look at that.
Yeah. The next one is the like this, which is also close to the randomization, but instead of grabbing values all over the place, it's trying to create solutions or results that are closer to a certain value that you assign. So you can see that the variables now became a slider, and here you can choose the value that you actually want to approximate that value to. So
I have a question about this one. Oh, go ahead, Ben.
I was just going to comment on this. Basically, if you were to run a cross product, or you were to run a few options with a few runs with the previous ones, but they're very low resolution where you don't have that many options, maybe you like something that this looks right, but I want more variation in this thing, and this kind of option that was generated, you could just choose those settings and then get something closer within this kind of train of thought, but just vary it from this point of view, vary that input.
Yeah.
Did you have a comment, Bill?
Yeah, so not a comment, but a question. I've heard it kind of explained when you get to the like this part of this tool, the Revit Generative Design piece, that it's almost like a machine learning light, in the sense that you're starting to tell the tool that, hey, I want to see options like this, and starting to tell the program, maybe machine learning's an overreach or an overstatement, but would it be fair to say that it's starting to inform the tool to start showing or do studies that are close to something? Like, again, where does some of these concepts start, of starting to talk about like what is AI or machine learning? Is this an element of that, or is it not?
Yeah, I wouldn't classify that as machine learning. Machine learning happens more with kind of a record of actions that you could kind of log, and then off of that record, the computer, the algorithm actually starts to predict that you want this because of previous actions that you've done. I learned that you prefer this, or you select this usually, so I'm going to make that decision proactively for you because of historic data. So that's where I would classify machine learning, and I wouldn't put this under that same umbrella.
It's a good clarification.
Yeah, in this case, is the user that is defining what is the value that you wanted to focus on, instead of being the machine. So it's actually user intelligence, not machine intelligence, right? So this is one of the examples that shows that the generative design is not trying to completely generate something without the user to have some saying. This is definitely the user trying to help the generative design tool to create options based on something that the user prefers over other things. So let's generate the options. Yeah, so now we can see that the options are a mix of the randomness, but it's not creating a lot of different options. They are very similar to each other, but it's still different.
Yeah, we could also tell by looking at the sliders actually that change there. You can see that the values in the sliders are not from 0 to 1, or they're not the entire gamut that we used to have before.
Oh yeah, here, yeah, this value is a fraction of what it used to be. Is that what you mean?
Yes.
So now we're going to show the next script, which is a modification of the workspace layout Dynamo script that comes automatically with Revit 2021. And I want to focus on the modifications I made. So what this script is doing is selecting a certain family, furniture family, and placing them multiple times inside of this room. And the parameters that it's taking to choose where to place it is the distance to the exit doors. And here in the background, we can see that we have two different doors, a certain distance that it's trying to keep from all the other tables, and also a relationship to the windows. So it's trying to give to these tables a better view to the outside. So it's optimizing to give to at least all the tables to have the capacity to see the outside from where it's standing. So those are the basic parameters it has. So
and is it already starting to inform that based on the red and color variations of the green?
yeah, so I believe that the color here is defined by the distance to the exit. And the further it gets from the exit, the redder or less green it gets.
Great.
Okay, so the modifications I did are in gray. And the modification I made was trying to change this workspace layout to work in a different setting that would be using a table for a restaurant. So instead of creating rows of multiple desks, one close to the other, it's trying to maintain a certain distance from all the tables. So let's this think a little bit. I just want to make sure we have a room selected, and I can select on this view. So I'm going to go to this view to select my room, and I want to select my desk, and here I'm going to reduce this. Okay, so to just finalize this, to start generating the options, here we're setting the goals, and we wanted to minimize the distance that the tables have to the exit and maximize how much views it has to the outside and how much desks we can actually put inside of the same room.
This is so freaking cool.
Yeah. Yeah, and yeah, this is one of the options, and here we can see how much rotation it's adding, the space between the rows, and the number of desks that we have changed. So this one has 19 desks. So this is possibly the very close to the maximum amount of desks that we can add to this room.
So then, as an example, then we could filter these out. You could filter out the maximum number of desks, being that top one, and the maximum amount of views to the outside. And I guess the other things we would want to maximize probably is average distance, depending on how much you like your neighbor, or any guidelines that you have.
Yes.
So this is cool. So like if I was a restaurant owner, Clara, like you could do a generative design study for my restaurant and say, hey, I want the max amount of seats because I want the max amount of guests to make the max amount of money. Also offering the best value being the views to the outside and giving them the most amount of privacy, average distance to other desks with this study. And this is a pretty complex shape too. I mean, if I was to kind of try to think about laying this out manually as a designer, I personally feel like it would be a somewhat challenging task to think about how I could, especially with the geometry that you have here, to try to execute that. I feel like this is a really good example of generative design helping problems solve that.
Mm-hmm. Yeah. Yeah, this is a cool solution. And I just want to add up, like maybe some people are wondering why closer to the door there are no desks, even if we're trying to minimize the distance of those desks to those doors. So the script itself is defining a limit of how close those desks or tables can be to that door as well. So you have more space in the door in case everybody's trying to leave at the same time for some emergency. So that is the reason why that's happening.
I think this is great. Can you guys comment quickly? What are your thoughts on, you're using this tool to help you do your job, right? So Clara, you have an architectural background. You worked at an architecture firm. Same with you, Ben. What is your guys' personal opinion about this? Do you guys feel like this tool or generative design in general is taken away from your creativity or your ability to problem solve? Or does it augment your ability to be able to do that? What's your guys' personal opinion on this tool? Because I think that's where a lot of people get a little defensive about some of these tools, how this just laid this out for you. Well, where's the creativity in that, or your ability to think for yourself and help problem solve? What's your guys' opinion on that?
So my opinion is that it is not. It's more augmenting your creativity, because it's it's helping you to create options based on what you believe it's the best parameters. So instead of trying to create one by hand and maybe spending so much time on that you can create be more creative in other areas of other studies. So it's actually like helping you to do this more repetitive work and generate more options that you can just evaluate later, other than taking away that delight of designing from you.
Do you have a comment on that, Ben?
Yeah, so I mean, this tool is as good as the Dynamo script. So if the Dynamo script is not that well thought out and the problem is not the problem that we're trying to solve, or the question actually is misasked and not answered inappropriately via the Dynamo script, which is actually the skeleton that allows for this tool to function and start to change the inputs around, then it will not really generate beyond what the script scope is. So essentially, a lot of the output that you see here and all the different options that get presented are really tied back to how you compose that script. So I do think that people really embracing visual scripting and really understanding how to set up Dynamo scripts and how to create those associations. For example, even in this example that we have on the screen, if we look at the desk placement, they're all kind of rotated in a matrix that is the same grid, a 90-degree grid that is rotated at a certain angle. And you can rotate that in certain variations, but the relationship from desk to desk is within that pixel grid that is a 90-degree grid. And it does have edge awareness, but to the extent that it's a pixel grid, where you could see that, let's say you had an arc floor plan where you start to array things. With this specific script that we have here, it's not built to handle a perimeter that is rounded or certain conditions in the plan. So it's just going to work with this kind of rotated on a pixel grid that gets rotated and spaced against that. So what would make that a success, for example, dynamically changing the perimeter of that will have to be baked into the logic of the script, so that the actual logic of the script is aware of that to a way where it actually angular arrays those objects if that's something that's desired. But the bigger point that I'm trying to make is that this tool, and it's a very powerful tool actually, we can use it with so many things. You don't have to sit in Dynamo and start to play with a lot of different inputs and wait for the whole graph to execute, especially for larger graphs. You could actually let this thing run for a few hours if you have a very complex a solution that you're trying to explore, and then actually get presented all these different options that you would have had to manually wait for the computer to crunch. So that aspect is very powerful, and I think this tool it's taking off within that domain. But I don't want to oversell this tool to tell or to broadcast that this is a solution for everything. Basically, it's another tool in our set of tools that we could use to assist design. And even after the few iterations, we could still look at, okay, well, maybe we manually adjust certain things this way, or it could assist you in that design. Or if you build the script smart enough and actually you set up the relationships really the way they're supposed to be set up, then you could see how this thing completely generates the floor plan or the arrangement of desks, so on and so forth. But yeah, again, to me, it's really a tool and a set of tools that is also dependent on the previous tools, Dynamo and Dynamo scripting Sometimes you need to know a little bit of Python too, and just to get those nodes working properly. So that's still not out of the picture. This is an overlay on that so that you could quickly iterate with what Dynamo does, and get those options straight into the Revit model. That connection is very important. Getting those immediately into the model is a very important button and feature that this tool provides.
And also, Ben, you commented on like, if there's a lot of iterations, just running the script overnight or running it for a few hours. Something is fascinating to me is like, if we have 8 to 10 hours to come up with a set of designs, do you guys feel generative design multiplies your time at all? I've been thinking a lot about this of like us having 24 hours in a day. Is there a time multiplier at all and a value to life as a designer that allows you to optimize designs and or give you more freedom of time in that sense, or to come up with the best option in the least amount of time? Is there an argument for that at all, or a counterpoint to that?
Definitely. So basically, when we transitioned from AutoCAD to BIM, everyone said it's going to be faster and it's going to be the way better to move from AutoCAD to Revit, and which was not the case to a certain degree. Meaning, it wasn't faster to draw a building in BIM. It wasn't faster because a lot of that work was shifted up front. You have to have all your if you had a template ready and you had all the standards set, then that would be faster. But because people were transitioning and they didn't have the templates, they didn't have. The analogy here is that you don't have the scripts, you don't have the relationships, and the way you build your dynamic script to build up design is not ready. So the time that it will take you to iterate through those 10 design options, let's say you would have to do it manually versus this route, I would argue that it could take even longer to do it this route. But what you're getting with this one is a lot more things up front. You're actually getting relationships between items. You're getting additional data of what were your goals. Were you trying to maximize this? So you don't have to, by changing right now the wall 10 feet or something like that, you run that same optimization again, and if you had to do another 10 of those, then it will take you way longer to do in the traditional sense. So the upfront, there's a cost of investment in the scripts and the logic and the relationships that you're building. So there might not be an immediate one right away, but as you expand that repertoire of scripts and relationships that you are part of that project's design constraints, and you script those, that's where you start to actually see benefits and start to reap the benefits of this tool alongside with all the data that is being generated. Like you would say, if you're maximizing views to the outside, you actually have that data to present right now because it's part of the reason why you ran this algorithm is to get that number. So instead of doing that exercise retroactively after the designer set up everything with kind of more of in the back of their minds thinking about views to outside, you actually have that data from the beginning because that's the data that was used to generate the design. So you get that additional thing up front, similar to how in AutoCAD versus a Revit, you got the condition of the actual building and the way that you're not using lines to describe geometry. You actually have a 3D model up front from the get-go.
And I want to add that with this process, you have to think more about, like, you have this time where you trying to understand better your problem. And I think that is also valuable to the design because it can actually help you understand your problem better instead of trying, oh, I'm going to try to place these tables here, and you don't actually have a reason to place this table here instead of that. So this process kind of guide you to be more conscient on the decisions that you're making while you're making them and why you're making them.
It's a really good point. Cool. Well, thank you for walking us through this, Clara. This is really exciting, and I'm very fascinated by the opportunities that we have here. Do you guys have any other thoughts or comments? Ben, I know it's your daughter's birthday today. You get a jet here. Do you guys have any final thoughts, comments that you would tell people that they should know about either generative design or more opportunities to learn, or where do people start, et cetera, et cetera?
Yeah, I think the one comment that I would have is if you haven't really given visual scripting a chance, I think this is more of a reason to even give that an opportunity and a chance. Because the more designers understand, it doesn't take away from quality of life. It doesn't take away from the designer's ability to express themselves. It actually emphasizes it. So and actually codifies the way you're thinking and the way you're designing into an algorithm fashion. So it actually codifies it into an algorithm and a relationship that you build with your visual script. So if you haven't given that a chance, I highly recommend that you give that a chance. And with this new release of Revit 2021 with the generative design tool, it just only amplifies whatever you've learned in Dynamo scripting and amplifies that aspect.
Yeah, and I want to point out that recently we had a blog post that is talking about the computational design features on Revit 2021, and I recommend you reading it because we are discussing some of the generative design tool features and like how to implement it, and also we're starting to create much more content on the learning and educational areas. So soon we're also gonna have more content on this area. So yeah, stay tuned to us.
Yeah, and someone really smart wrote that blog post about the new Revit 2021.
I don't know.
Cool. Well, thanks, Claire. Thanks for showing this, Ben. Thanks for educating us on your experience on it as well, and your comments. They're always super insightful, and always gain so much knowledge when I sit down with you guys and learn from you guys. So thank you for sharing this.
All right, of course.
Definitely, our pleasure.
Thank you for having us.
All right. We'll see you guys.
See ya.
Bye.